All right, let's dive into something that is genuinely mind bending today. We're looking at a research paper that puts forward a totally radical new theory of gravity, and honestly, it might just change how you think about the ground you're standing on.
So, get this. The theory basically asks, what if gravity isn't about mass pulling on mass like we all learned in school? What if, instead, it's just a side effect? A an emergent phenomenon that's happening because of a quantum level dance between every atom in your body and the planet itself. Okay, to get our heads around this, we have to start small, and I mean really small. We need to look at this strange little property that certain atomic nuclei have, because it's the foundation for this entire idea.
It all comes down to something called a nuclear magnetic moment. Now, don't worry about the term. All you need to know is that certain nuclei, think zinc or bismuth, have this quirk that makes them act like microscopic compass needles. And just like a compass, they're always trying to line up with whatever magnetic field they're in.
And this is where it gets really cool. The nucleus doesn't just snap into alignment, it wobbles. The technical term is precesses. But honestly, the best way to picture it is a spinning top. You know how it kind of wobbles while it spins? It's doing that. And this tiny, tiny atomic wobble is the absolute hero of our story today.
Now, here's the thing. This wobble isn't just a passive little dance. Scientists figured out they can actually manipulate it. By zapping the nucleus with a very specific radio frequency pulse, they can give it a little push, knocking its magnetic moment into a new orientation.
So, this ability to nudge a single atom's wobble leads to a massive question, right? If you can push the magnetic moments inside a material, can you push the entire material? Could you actually create movement from, well, thin air? And this is no longer just some thought experiment. The researchers behind this paper set up a really clever experiment to see if they could actually pull it off. To do that, though, they needed a very particular kind of material.
So here's the setup. They took a disk made of bismuth, which, again, is perfect for this because its atomic nuclei do that little wobble, and they put it inside a magnetic field. This lined up all those tiny atomic compass needles.
And then came the incredible part. They hit it with a radio pulse, and the disk physically turned. Just let that sink in for a second. They used a radio signal to create actual mechanical work. This was the first huge piece of evidence suggesting you could convert RF energy directly into motion.
But they didn't stop there. They did it again with rods made of zinc and titanium and found something even crazier. Depending on how the rod was oriented in relation to the Earth's rotation, the radio pulses could actually change its weight. So we've gone beyond just motion. We are now talking about directly affecting the force of gravity itself. All right, so let's take this to the next level. How do we get from a little disk spinning in a lab to a theory that could potentially explain one of the fundamental forces of the entire universe? This is the giant leap. The researchers asked, okay, if a tiny RF pulse from our equipment can affect a nucleus, what is the effect of the Earth's ginormous magnetic field and its constant massive rotation doing to every single atom on the planet all the time?
Now, this whole interaction is apparently governed by a fundamental law of physics, the conservation of angular momentum. It's a fancy term, but the idea is pretty simple. For any spinning system, if you change one part, another part has to compensate to keep everything in balance. And this slide really shows you the mechanism at play. As the Earth spins and carries an atom along, that atom's speed relative to the magnetic field is always changing. So to conserve that angular momentum, to follow the rule, the radius of its little wobble has to constantly shrink and expand to compensate. And it is this continuous adjustment that creates a constant net inward force. And here it is. This is the central, mind-blowing question of the whole paper. Is that constant inward force, the one generated by trillions upon trillions of atomic wobbles, all adjusting to the Earth's spin, what we've been calling gravity this whole time?
Look, if this theory holds even a little bit of water, it doesn't just rewrite a few textbooks, it blows open a whole universe of new possibilities. It forces us to re-examine things we were absolutely certain we knew. And the potential applications here are just staggering. If you can turn RF energy into motion, that could completely revolutionize industry. If you can control inertia, that changes everything about aerospace. And what about astronauts? Is the microgravity they experience really because they're far from Earth's mass? Or is it because they're no longer moving in sync with its very specific spin and magnetic field? And this could totally change how we think about biology in space. I mean, the human body is mostly water, which is full of hydrogen atoms that are highly susceptible to these kinds of effects. So maybe the health problems astronauts have aren't from a lack of gravity as we know it, but from being taken out of the Earth's unique electromagnetic environment that our bodies have evolved in for millions of years.
The best part is, this isn't just speculation. The researchers have proposed a really clear, kind of beautiful experiment to test this whole thing. Get in a plane, fly with the Earth's rotation, and then fly against it. If their theory is correct, an object's measured weight should actually change depending on which way you're flying. It's a simple but incredibly powerful test of a revolutionary idea.
And that's where we're left. This paper offers up experimental evidence and a compelling story that forces us to ask this question. It suggests that maybe, just maybe, gravity isn't a fundamental force at all, but is instead the beautiful collective result of a secret atomic dance, choreographed by the spin of our own planet. And that is a very provocative thought to take with you.